Yes friends, so we are continuing with question number 10 here. Okay, so what is the question here given? We are given an original cone, right circular cone, in which a frustum is cut by a parallel plane which is parallel to the base. Okay, now let me again read the question number 10. A right circular cone is cut parallel to its base at a half of its height. At half of its height. Half of its height. Okay, that's the point given to us. So half of its height, this is cut. Then we have to find out that what is the, sorry friends, half of its height. What is the ratio of the volume of the frustum formed to that of the original cone? That's the point. Okay, so original cone. The original cone is this. Now it says that a frustum is cut at half of the heights. Half of the height, suppose total height is h of the cone, and this base, this top is cut off the frustum at h by 2, that half of the height. Okay. Now we have to find out that what is the volume of the frustum to the original cone. I think a right circular cone is cut parallel to its base at half of its height. What is the ratio of the volume of the frustum? First volume of the frustum we have to find out, formed to that of the original cone. So original cone's volume we have to find out. And what is given? Let me write here. We are given a right circular cone. A right circular cone cut by a parallel plane to the base at half of its height, to form a frustum. Okay, so in this way a frustum is formed. To form a frustum at half of its height. This is given to it. At half of its height to form a frustum. To find here, what we have to find out? To find the ratio of the volume. To find the ratio of volume of frustum. Okay, ratio of volume of frustum to volume of original cone. That is the point. Okay, that we have to find out. Now the solution. Try to understand this now. Now in this case, this is a triangle OEF. I have taken these sides as A, B, C, D, E, F and O. O is the vertex of the cone, original cone. Okay, so the two triangles O, E, F, I have taken a smaller r as the radius of the top of the frustum, and the capital R is the base of the radius of the base of the cone, original cone. Now point is that what is the relationship between the small r and capital R? Let me find out by similarity of the triangle. Now this triangle OEF is similar to triangle OCB. Since, let me write here, since triangle OEF is similar to triangle OCB. This implies that the corresponding sides are proportional. Why they are similar? By A is similarity. They are similar. This angle is common to both triangle, this one and this right triangle. And this angle is right angle, this angle is right angle. Similar corresponding angles. This angle is equal to this angle. The third angle is also equal. This also corresponding. This line is parallel to this. This angle is also corresponding angle. Okay. So by angle similarity, these two triangles are similar. Their corresponding sides are in proportion. Therefore, let me take the smaller triangle's side first. Is radius of the smaller triangle divided by capital R is equal to height. What is the height of this smaller triangle? H by 2, because this is H by 2, this is also H by 2. So H by 2 divided by total height of the cone is H. This is equal to 1.2. That means this implies that smaller r is equal to capital R by 2. So this relationship is that this is half of the original of the radius of the base. So small r is equal to, we have just calculated, this is r by 2, capital R by 2. This smaller r is now calculated in terms of capital R. Okay. So this is one point we have calculated. Now let us use this to find that what is the volume. Now volume of the frustum. First let me find the volume of the frustum, because volume of the frustum must be in the numerator. Then to the volume of the original cone ratio of, then we have to find out. So volume of the frustum of the cone is equal to, we know that this is what is the volume, 1 by 3. Okay, this is pi into capital, this is r square. The small r square means r by 2. Now because the small r is r by 2 here, r by 2 whole square. Okay, into h by 2 is the height, r by 2 plus r into r by 2, r into r by 2, the square root of these two, because r by 2 is square root of this r by 2. This is mean of r and r by 2. This is within the bracket, into h by 2 into h by 2, the height of the frustum. Let me find out finally what is this value. This is h by pi h by 3, 2 is 6, this is 6 here, because this h by 2 and 2 into 3, 6. So pi h, this h I have taken first, pi h by 6, okay, into within bracket, what is this? This is r square upon 2, okay, let me write r square plus r square upon 4, because r by 2 whole square, plus r square by 2. Now let me add these. So 4 is LCM in the denominator, so this is pi into h divided by 6 into 4 LCM, which will be 4 r square plus r square plus 2 to the 4, so this is 2 into r square. Finally, so this is r square plus 2r square, 3r square plus 4r square, 7r square. Okay, so 7r square, let me take here. This is volume of the pi into total this area of the base and top and mean of the base, and this is total solution. Now let me finally solve it. Therefore, volume of the frustum we are calculating. We have to find out the ratio of the volume of the frustum to the volume of the original cone. Find the find what is the ratio of the volume of the frustum formed to that of the original cone. Okay, therefore volume of the frustum we are calculating. Therefore volume of the frustum volume of the frustum. Okay, volume of the frustum is equal to, here this is 7, because 7 r square plus 2 r square. Okay, so this is 3r square plus 4r square, 7r square, 7 into pi into h r square upon 6 into 4, 24. 6 into 4, 24. 24 in the denominator. This is first equation. Let me take this as the first equation. This is the volume of the frustum. Now volume of the original cone. Now we know that what is the volume of the original cone. That is 1 upon 3 pi r square base area of the base into height. Height is h, and the volume of the original cone. This is and volume of the original cone. Let me find out. Volume of the original cone is equal to pi 1.3 pi r square. This r square radius, pi r square area of the base, 1.3 pi r square into h. Okay, this is second equation. So dividing first by second, what do we get? Let me find out this. Therefore, ratio. Let me find out that. Therefore, ratio of the volume of the frustum divided by volume of the cone. Volume of the cone is equal to this is 7 pi into h into capital R square divided by 24 divided by 1.3 pi r square into h. Now see here, pi r square h, pi r square h cancel out. Only numerical values are left. So 3 will come in the numerator. 7 3 are 21 upon 24. So this is equal to 38. Here, so finally ratio is what? 3 into 7 in the numerator. So this is 21 upon 24. So if I cancel out by 3, 3 7 is 21, 3 8 is 24 upon 8. So ratio is 7 is to 8. This is the answer. Okay, so ratio of the volume of the frustum to the volume of the cone is 7 is to 8. Okay, so this is question number 10 we have completed. Now let me talk about question number 11. What does question 11? I think this is related to this figure, this question. Next question is related to question number 10. What does it say? It says that in question number 10, let me first read it and then solve it. 11th question says, in the question number 10, okay, the same basis. In the question number 10, what is the ratio of the slant height of the frustum found? So slant height of the frustum we have to find out to that of the original cone. Slant height of the original cone and slant height of the frustum of the cone. In this case, question number 10 related to, so this is question number 11. Okay. In the question number 10, okay, with the same basis, I mean question 10 is the basis of this. I mean this frustum is cut at, or this, I mean by a parallel plane to the base at half of the height. Then what is the slant height of the frustum? What is the ratio of the slant height of the frustum to the slant height of the cone at the point? In question number 10, what is the we have to find out. In the question number 10, in question number 10, having the same base and the height of the cone and the frustum. And the frustum. Okay, same thing, same radius base, having the same base and height of the cone and the frustum. Okay, to find what the ratio of a slant height, ratio of the slant height of the frustum to the slant height of the original cone. slant height, let me change this, slant height of the original cone. Okay, that we have to find out. Slant height of the original cone. Now that is the point here. For the slant height, if I have to find out, let me draw a perpendicular from here. Now this perpendicular, now here it is r by 2. This is r by 2, small r is equal to. So this distance r by 2, this is r by 2. So this will remain r minus r by 2. Okay, so this distance is r minus r by 2. This one base, and this is h by 2. So slant height is this, suppose L1 is the slant height, and this slant height was L. L is total, this slant height of the original cone. Slant height of the original cone, or L, and this is L1 suppose. So let me first write solution here. First finding the slant height, since slant height of the cone. Now let me take this C, D, E, F, G. This is G point here. So F, G, B in right triangle. Slant height of the frustum from the right angled triangle FGB. FGB. This is right angled triangle. This is hypotenuse square. That means L1 square is equal to FG square. This is FG whole square plus BG square. Okay, so this will be, let me take L1 square root of, what is FG? Now FG is h by 2. So this is h by 2 whole square plus BG. This BG is r minus r by 2. That means r by 2. Because this is half, r minus r by 2 means half only, r by 2 whole square. So L1 has come out as h square plus r square upon 2 square root. Out of square root we have, so slant height of this is equal to, let me write here. So slant height of the frustum is equal to under root h square plus capital R square whole divided by 2, because the square root is taken out of 4. Okay, so this 4 has come out because 4 was in the under the square root, and out of the square root this 2. The square root is only in the numerator. Okay, so this is slant height of the frustum. This is equation number 1. So let me find what is the slant height of the cone. So slant height of the cone, as we know, this is total h and this is r. So in right triangle OCB, solution we are finding out, and slant height of the original cone OAB cone from right angled triangle OCB. What is this? This is L. So L square is equal to h square plus r square. Why? Because this is h and this base is r, capital R, radius of the base. So h square plus r square, we know that slant height L square equal to, in the cone we have discussed already. So L square equal to h square plus r square, or L is equal to under root of h square plus r square only. This is second equation. Therefore, ratio. Now we can find out what is the ratio. Therefore, ratio of slant height of the frustum to the slant height of the cone, to the slant height of the cone is equal to, now this is L1, let me take L1 upon L. L is the original one, slant height, and this L1 is of Frustum, and Frustum, this is from first and second. This is under root h square plus r square, under root h square plus r square upon 2 upon under root h square plus r square only. Okay, so this we have obtained. So finally what we have obtained, this numerator cancelled out, this is only 1 upon 2. Ratio is 1:2. Therefore L1 is implied that L1 is to L is equal to 1:2. This is the answer. So ratio of the slant height of the frustum to the slant height of the original cone is 1:2. This is answer. Okay, so this is the process of finding ratio of the slant height of the frustum to that of the cone. Okay, so this is the answer. Let us take now question number 12, the last one. So question number 12, what does it say? Let me first write it down, that what is given to us. I think same type of cone is given, but let me draw cone again, no problem. Okay, now question number 12. Question number 12 is, now it says, a right circular cone is cut parallel to its base at 1/3 of its height from the base. What is the ratio of the volume of the smaller cone formed to that of the frustum formed? Okay, so again, this is a cone, original cone. Again, there is a frustum formed at the height 1/3. Total height is suppose h. This is h here from this point to base. Now this is h by 3. It's a 1/3 of the height. So this height is h by 3, 1/3. Remaining will be 2 by 3 because h minus h by 3. So this is h minus h by 3 equal to 2h by 3. So 3h minus h means 2h by 3. And this height is 2h by 3 from this point to this. So this cone is I mean the smaller cone. This is smaller cone, this is the bigger cone, original cone, and this is the frustum. So h by 3, 2h by 3. Radius, let me take base r, radius. And what is the radius of this one? This radius, suppose this is small r, so relationship between small r and capital R we have to find out. Let me take again A, B, C, and this is D, E, F. Okay, this is F here, and the small r is the radius, and this is O, original point. What is the relationship? Now what is given to us? Again given a right circular cone, a right circular cone, a right circular cone which is cut at 1/3 of the height to form a frustum. Okay, to form a frustum from the base. What is that? 1/3 of the height to form a frustum from the base. 1/3 from the base. This is 1/3 h by 3. The remaining height is 2h by 3. Okay, so original cone to the frustum, the smaller cone, I think the right circular cone is cut parallel to its base at 1/3 of its height from the base. What is the ratio of the volume of a smaller cone? So volume of a smaller cone, this is height for the smaller cone. Now slant height not required, only radius is required. So what is the smaller r? That we will find out. To find here, we will find out ratio of volume of the smaller cone to the ratio of the volume of the smaller cone here. ratio of volume of a smaller cone to volume of the frustum. That is the required thing. The volume of the frustum and the volume of the cone, smaller cone, we have to find out. So the radius here, r, small r. The radius of the top base of the frustum. Let me find out that first. Now, radius of the top of the frustum, radius of the top of the frustum is this. Small r, I have taken smaller r, but that smaller r can be taken in terms of capital R. So what is that? Radius of the top of the frustum from similarity of the triangles. Why similarity? Because the two triangles are similarity of the triangles. From similarity of the triangles. Okay? Which triangles? Triangle OFB, OEF, this is E. OEF and OCP. This triangle, since triangle OEF is similar to triangle OCP. So what is that? So let me take smaller r, the radius of the smaller triangle to the original triangle is capital R, the bigger triangle, and this height 2h by 3 of the smaller one, and the larger one is h by 3. This original one is h only. This is nothing but 2 by 3, so the h is cancelled out. 2 by 3. So r is equal to 2r by 3. So smaller r, finally we have obtained. Smaller r is 2r to capital R upon 3. This is smaller r. Smaller r is 2 into capital R upon 3. So in terms of capital R, I have calculated from similarity of the triangles. Why? So because this is required to just calculate the ratio. So this is the radius, smaller r, relations between them. Now let us find what is the volume of the frustum and volume of the original cone. Now volume solution we are finding out. Volume of the smaller cone. First let me find out the smaller cone. What is the volume? Volume of the cone 1.3 pi and area of the base. Area of the base is pi into radius is what? The smaller r is 2r upon 3 whole square into h. Height is 2h by 3 of the smaller cone. Try to understand. Pi r square h, pi r square. But r radius is smaller r here, so smaller r is 2r by 3. We have just calculated. So this is in case of a smaller cone. This is smaller cone. So what is the volume of this? Pi r square h. R means radius of the base of this smaller cone. So radius of the smaller cone, base of the smaller cone is 2r by 3. 2r by 3 whole square. Pi r square into h. H height of the smaller cone is 2h by 3. We just calculate it. Let me now find out. It will be 2h by 3, 2h by 3. This is, okay, let me take 1.3 pi, and this is 4 into 4r square upon 9. This is 4r square upon 9 into 2h upon 3. With the final value, let me just write here. The volume of the smaller cone is, okay, this is 9, 3 are 27, 3 are 81, 2 4 are 8, so this is 8 pi r square into h upon 81. Try to understand. 8, 4 2 are 8, r square into h pi r square into h, okay, upon 81. 3 9 are 27, 3 are 81. This is 81 here, 27, 3 are 81. This is first equation. Now we have to find out what is the volume of the frustum. The volume of the frustum will be, this is first equation. Now